So from this we have to find out the value of small d. So d is equal to 0 minus 0.423 plus minus root over minus 0.423 whole square divided by 4 multiplied by 0.29 by 2. So we know this Acharya's formula. From this we can calculate d, that is equals to 367 0.367 meter or 367 mm. Okay. So by two-way shear criterion or punching shear criterion, we get the value of d is equals to 0.367 meter. Okay. Now we have to go to next step. Next step is depth of footing by bending moment criterion. So critical section is at the face of column, bending moment at the critical section, mu is equals to 251.85 into 2.25, 2 within bracket 2.25 minus 0.45 by 2 into 2.25 minus 0.45 by 4, that is equals to 566.66 into 1.80 square by 8 is equals to 229.498 kilonewton meter, that is equals to 229.498 into 10 to the power 6 Newton meter. Okay, so these all formulas I have discussed in last video. You can check with this video and tally this the formula and these values. Now moment of resistance at critical section is now xu max by d is 0.48 for Fe 450 steel and Ru is equals to 2.76 for M20 concrete and Fe 415 steel. So in last video I have shown you the value of Ru which we have calculated and made a table. Let's check again. So for Fe 415 steel and M20 concrete we have to check out the value of Ru. Okay, so let's see the table again. So this is the table. So for M20 concrete and Fe 415 steel, K or Ru is 2.76 Bd square. Okay, so Ru is 2.76 as per the table, where Ru or K is 0.36 xu max by d within bracket 1 minus 0.42 xu max by d bracket closed into FCK. So from this table we can find out the value very easily. This table calculated by oneself. Okay, so this table is not given in Hays code. So you have to, as per the question, you have to remember a few values that will help you, and that is a shortcut to solve the problem. Otherwise you can use directly the equation from NXG. So you can use that procedure also. So as you see, the value of Ru is 2.76 for M20 grade of concrete and Fe 415 steel. So mu limit is equals to Ru into B into D square, that is equals to 2.76 into 2250 into D square, that is equals to 6210 D square. So this is equation 6. Now we have to equate equation 5 and equation 6. So by equating equation 5 and equation 6 we get 229.498 into 10 to the power 5 is equals to 6210 d 10 d square So D is equals to 192.24 mm or 0.192 meter. So from equations A, B and C, the highest value of D obtained is for one-way shear criterion, that is 0.396 meter or 396 mm. So let's adapt D is equals to 400 mm. So overall depth will be 400 plus 8 as we take 16 mm diameter bar, and plus 50, where 50 is taken as clear cover. For footing we have to take minimum clear cover of 50 mm. So overall depth is 458 mm, say 460 mm. Now we have to calculate area of steel reinforcement. So this equation is from Annex G of IS 456 2000. Mu is equals to 0.87 Fy into AST into T within bracket 1 minus AST Fy by BD FCK. Therefore 229.498 into 10 to the power 6, that is the value of mu, is equals to 0.87 into 415, that is Fy, into AST, which we have to find out, into 400, that is D, within bracket 1 minus AST into 415 by 2250, that is B, into 400, that is D, into 20, that is FCK, or AST square minus 43,369.37 AST plus 68918,318.32 equals to 0. So again we have to apply Acharya's formula. So AST is equals to 43,369.37 plus minus root over of 43,369.37 square minus 4 into 68918,318.32 by 2, that is equals to 1652.03 mm square. Now this much area of steel is required, so minimum reinforcement required is 0.12% of area. So 0.12 into 2250 into 460 by 100, that is equals to 1242 mm square, that is less than 1652.03 mm square. Using 16 bars, so a dia that means dia of one bar, area of one bar is equals to pi by 4 into 16 square, that is equals to 201 mm square. So spacing should be 201 into 2250 by 1652.03, that is equals to 273 mm. So provide 16 dia bars at the rate 270 mm center to center in each direction. Okay. So this is the design data. Now we have to draw. So this is the elevation and this is the plan. Okay. So elevation, in elevation you can see the column is 450 mm and here is the footing, which is 2250 mm, and the depth is 460 mm, clear cover is 50 mm, and 16 mm dia bars at the 270 mm center to center in both direction is provided, and the plan is looks like this. This is the plan. So that's all for this lecture. But before at the end we have to check for development length. So development length, we have to follow clause number 26.2.1.1 of IS 456 2000. Okay, so LD is equals to 0.87 Fy into phi by 4 tau bd, that is equals to 0.87 into 415 into diabar 16 by 4 into tau bd is 1.92 for M20 concrete and Fe415 steel as per IS 456 2000, that is equals to 752.2 mm, and available length of bars is 2250 minus 0.45 by 2 into 1000, that is 900 mm. So this is greater, hence okay. That's all for this lecture. Thank you for listening.